The Square Kilometre Array, or SKA for short, is going to be the largest telescope ever conceived. Not only is it going to be of order 50 times larger than any telescope we've ever built, but it's also going to look at the sky in an entirely different way. One of the things we hope to do is look at large chunks of the sky all the time. So rather than just pick a particular interesting little patch and stare at it, by looking at the whole sky all the time, we can see things happen that we might not have expected. We've known for about 30 or 40 years that the whole universe is full of magnetism. And this magnetism is important. It helps stars form, it helps planets form, it protects the Earth from solar flares, it helps birds navigate. This magnetism is everywhere. It's much more than just what holds something to your fridge. But we have no idea where this magnetism comes from, and we don't know why it stays around. We know that magnets were formed very early on in the universe, but this magnetism has hung around for billions of years. A fridge magnet does not last billions of years. You need something to keep that magnetism alive. And by doing new types of observations with new types of telescopes, I hope to understand in the next few years why the universe is magnetic and what this magnetism is actually doing. How does it affect everything we see in the universe? There's a lot of reasons to want to do astronomy from Australia. In fact, I was living overseas in the United States for almost 10 years, and while I was there, I actually spent most of my observing trips coming back to Australia. One of the big advantages is that if you want to understand our own Milky Way, which is a very nice benchtop for understanding more distant galaxies, then most of the stars in the Milky Way, including the ones towards the center of the galaxy, can only be seen towards the southern hemisphere. We live in a house, our solar system, which is on the edge of a big city. And it turns out that the southern hemisphere is the windows of the house facing towards the CBD, and the northern hemisphere is the backyard looking out towards the country. So if you want to see all the action, you need to be in the southern hemisphere. One of the real strengths of the University of Sydney is its experience in history and radio astronomy. Some of the founding researchers in the field of radio astronomy are from Australia, and in particular are from the University of Sydney. So one of the real advantages I had in being a student here back in the 90s was the training that I received. I then moved overseas for many years, and one of the things I wanted to get up to speed on by moving was different types of astronomy. Australia's traditional strengths are radio astronomy and optical astronomy, simply looking through a telescope at the night sky. But there's a whole window of other types of radiation out there that Australia isn't that involved in. In particular, right now is the golden age of X-ray astronomy. The same X-rays that we use to look at a broken bone are being produced by violent, energetic objects all over the universe. These X-rays are completely blocked by the Earth's atmosphere. So a telescope on the ground or on a mountain simply cannot see these X-rays. You have to go up into space. This is where places like NASA excel, and I have spent the last few years working extensively with some beautiful data from NASA's Jewel, the Chandra X-ray Observatory that was launched in 1999. So by coming back to Australia, I brought a huge amount of X-ray experience and connections and calibration, and I've also brought a huge amount of connections and collaborations and networks relating to my experience in the X-ray game. So one of the things I hope to see over the next few years is that through my group, the University of Sydney will become a regional centre of expertise for X-ray astronomy, something that really Australia doesn't have much of a presence in. And I'm already training students and hiring staff who are helping make that happen. So we aren't in a capability to build our own billion-dollar satellites and launch them right now, but we can certainly reap the benefit of what other countries have put up there and help make new discoveries that come from Australian people, Australian students, Australian ideas.